Very good morning. I guess at this time it's almost not anymore morning, but it's not yet 12 o'clock, so morning is still appropriate. I'm glad to see so many of you here. For the next 30 minutes or so, we're going to dive into under data review energy savings. I do my best also to leave time for your questions, so don't run for lunch before we finish the session. You will have an opportunity to ask questions as well. So my name is Emilia Haapala. I come from ABB, Motion specifically. I'm digital lead of Motion business area, and I lead our IoT solutions business line. I've been working in the industry for as long as I've been working, if you like. I'm not going to say how long. And for the last 6 years, I've dedicated on bringing the benefits of digital technologies to solve some of the biggest problems on this planet. I'm going to warm you up with a little video, and then with the question.
Is transformed into motion everywhere, all the time. You flip a switch, and a dark room is immediately flooded with light. Your coffee brewed. Your music played. Electric motors and drives enable us to move, produce, grow, and thrive. But to do all that, we need energy, a lot of it. And with our growing population, urbanization, and rising living standards, we'll need even more. At the same time, to fight climate change, we need to reduce carbon emissions. The good news is, we can do better.
And I promised to ask you a question. So now it's time to warm up your shoulder joints. So how much of the world's electricity, total electricity produced in the world, how much of that do you think is consumed by electric motors and turned into some kind of electric motion? Those of you voting for A can raise your hand now. Okay. And then those of you who are voting for B. Nice. Thank you. You're absolutely right for the B. So majority got it right. Thank you. 45% of all electricity we produce on this planet is used in electric motors. It's not nothing. It's quite something. And so why would that be the topic I'm talking about? Well, because I come from a business that has been in the energy efficiency business for over 100 years. We're a company that has innovated more efficient motors and drives that fundamentally save energy in industries, infrastructure, and transportation. And now we're taking that to the next stage through digital technologies as well. We actually anticipate that in by 2040, that demand will double because the world is going electric. So whereas having renewable energies, having all kinds of actions, having carbon traps, producing less, are all good means to protect the planet, energy saving through industrial motors or motors in general is actually a big deal on that picture. It's one more person carrying the water to the bucket of sustainable future. Do you know how much energy your facility, be it your office, be it your plant, is wasting? Do you know? Any idea? How big is your saving potential? How much waste is there? Does somebody know? No? Okay. Fair point. That's why we're trying to bring the transparency to those figures using actual measured data. Before I talk more about that solution, I will mention a few things about how this looks like in a bigger picture. Together with some significant partners such as Microsoft, Alfa Laval, DHL, ETH Zurich, we published an energy efficiency playbook last November. Some of you may have seen it, some of you may not have seen it. But it has 10 actions that are doable, mature enough, and stable enough to do today to reduce energy in industries. This is very timely now for two reasons. One, sustainability is no longer an option. It's a must. Two, energy prices are bankrupting people and companies. When we want to address energy efficiency opportunities, we start from what? Auditing, right? And that's nothing new. We've done this for decades. Energy efficiency audits are not a new business. It's been happening for decades. And it's a good way to reveal potential. But it's a window in time. It's the pen and paper man who comes in and walks through your facility, marking down everything they see, looking at your data that you may or may not have collected and the reliability of which may or may not be there. But it's still good. I'm not saying it's not. It's the first step. But what if that could be done more automatically as well? The most common ways of actually then acting on the findings are the four as follows. And I'm now intentionally only showing you 5 out of the 10. There is 5 more that are very valid, but for today's purpose, these are the most key ones. Right-sizing assets. We've connected tens of thousands of assets. And the amount of time we find out that a motor is not even the right size to do its job, it's too big, is pretty interesting, I would say. When a motor is too big, there's one problem. You run it under its operating point. What does that mean? It means its efficiency is even worse than that one which was written on its data sheet, which is probably pretty bad because 300 million motors out there are mostly, majority of them, very low efficiency. They may not even have an IE class. Those of you who know what that is, it's a class system for motors on how efficient they are. IE 0, 1, 2, 3, 4, 5. 5 being the most efficient, 0 being the least. And when they don't even run in that point where they are intended to run, they're even less efficient. Now, obviously, the topic of the day is bringing connectivity to those assets. I'm not going to stop there right now, but I'm going to point out a couple of other things. Changing those motors to be more high-efficiency motors is a very good way to make very big savings very fast. Up to 40% saving is possible. Is it practical to take a whole plant and start thinking about, okay, I need to change all of these 100 motors? Probably not. However, having data at hand which is dynamic and which is not just the short window of time, but reflect the actual operations over months, maybe even a year, will point out exactly which ones are the ones that you should be changing. Good news, those of you who are worried about me talking about changing things that work still, is actually that motors are almost 100% recyclable. They're metal, so we can reuse most of it anyway. Energy is needed, though, to manufacture the new one, so some kind of a balance on when something should be changed is appropriate. Last one, variable frequency drives or variable speed drives or whatever you want to call them, are ultimately boxes that will drive the motor the way it should be driven. What do I mean by that? You don't drive a car by putting the gas pedal all the way down and then controlling the car by a brake. But this is what we do on over 70% of industrial motors. We push the gas pedal to 100 and then we push the brake. Not very sensible, but that's what we do. Over 70% of motors work that way. The drive adds the control on it, so we don't push the gas pedal down all the way, we just push it just enough. And in those cases, saving potentials are 70% sometimes. Why I love being in this spot in the industry and technology is because this is important. We are going to make a difference on whether we will reach the energy and sustainability and net zero targets and get to use technology to do it. IoT technologies are starting to mature. Now, you may agree or disagree with me on this, but I tell you, they're stabilizing. There are solutions that are robust, they're pretty easy to install, and they work. And the best part is, if you want to leverage industrial IoT to identify those potentials of energy saving to the last drop, you can do that and the rest of the nice stuff that technology does. So this is not something new. It's not an additional thing we are bringing into the picture. It's not an additional piece of technology that is needed to go to the energy savings. No, this is the same stuff we use for condition monitoring, machine health, predictive maintenance, condition-based maintenance. So if your fleet's already connected, you already hold the keys to reveal your energy saving potential in your hands. If you don't, then you have two good reasons to do it. By collecting data over time, we get much more reliable picture of a production line or of a building, by that matter, because there are a lot of things that are not used in one way all the time. This is the weakness of making spot measurements to actually realize savings. The second thing is, if you just do something and then you trust that there's an outcome, well, maybe there was or maybe there wasn't. Did you actually check after that you got those savings you thought you were going to get? Probably not. Most people didn't. They might look at their energy bill at the end like, okay, maybe I saved a penny. But the problem is we don't have a way of validating. And adding that into the IoT loop, we add a way of validating as well. So we can baseline and then we validate. So that gives a whole new level of reliability on the actual outcomes that we're wishing to have, which are maybe sometimes these days more obvious to your energy bill as well, because energy prices, I don't know, 200% up in a lot of countries. And lastly, as I said, it's not practical to think you're going to replace things, all of the things that might have a potential. So understanding the load, the behavior, and the biggest potentials of the whole fleet, for example, will help make investment decisions at stages, in stages, to realize the biggest benefit and the fastest return on investment. And this does not obviously just concern a machine, it concerns the load. We can add that domain expertise, not just of the machine itself, but of the most common loads which we have worked with for decades, if not a century, and compare the load curves to those efficiency curves to make sure that we get every last piece of it. A lot can be done also for not replacing stuff. It's not just replacing or adding something, it's also how are you running things, or not running them, by that matter. We find a lot of cases where something is just run very shortly, very hard, and then nothing happens for a long time. Why do you need that to stand by in your system? Maybe you don't. We also see that, as I mentioned, things are run in an unoptimal operating point, not necessarily because the machine is not the right size, but because the process was built maybe 10 years ago, maybe 20 years ago, and maybe you changed something in the process that has now changed the dynamic of how it consumes energy. All of this can be now brought in and front and created the transparency to make better decisions on how you can save energy. I have another question for you so that your shoulder joints get a good exercise today. So, what if we would adopt the high efficiency motor systems everywhere on that 300 million motor population? How much of the global total energy consumption could we save? 1%? Anyone? Now you already know my logic, huh? I'm predictable. 10%? Yeah. That is absolutely true. So think about that number. I'm not saying this is, let's put it this way, it's not necessarily realistic to actually reach that number, because that would really mean we change everything that is inefficient today, but that's the potential out there. Now, my favorite thing always when I do this presentation is also kind of like say, hey, we eat our own dog food. What do I mean by that? We actually do this in our own facilities, and we get learnings from that, and we share those learnings. There's going to be further reports, one for the Playbook on the economic and climate impact of those 10 actions, and two, our own current status towards our pledge of energy efficiency. In our Helsinki factory, it's the largest factory we have, largest drive factory in the world, not just ours, but everyone's. And we use our own IoT technology there to optimize energy consumption of the building. Our ventilation drives are all connected to the cloud, NB-IoT technology. Our pump motors have smart sensors, and we know what the building's doing, and we've identified some significant savings, especially when it comes to the usage of heating and ventilation. So really stay tuned. We're going to have some further materials out on what are the impacts we've created so far through our own facilities, but we're definitely leveraging this ourselves as well. So let me just put this together for you. One, energy efficiency is not an option. It's not an option, it's a must. If you think about the whole net zero and sustainability as a, I don't know, a 1 million liter bucket of water you need to fill, it's going to fill faster if you have more people carrying the water. Caring about these energy efficiency actions and taking them to the next level, revealing the data behind, is going to be another man or a woman carrying the water to that pool. The second thing is, we have now the opportunity to make better decisions through combining data, which gives us much, much more information on over longer periods of time how assets are being used, combined with the understanding of how that process should run, is that asset right-sized? Do we need that asset in the first place? And is it being driven the gas pedal all the way down or not? This goes also on to how we interact with the regulatory compliance. And lastly, implementing those things, especially the 5 that I talked about today. There's 5 more, and go look at them if you are interested. But those 5 more, they really are delivering results on CO2 reduction and energy cost reduction from anything between 5 to 40%. It's significant. And there is typically relatively low return on investment when you apply, especially these IoT-based technologies, to identify those opportunities and take the action therefrom. So, with that, my ask to you is, let's put our heads together for a more energy efficient future. Thank you so much. Now, those questions. What questions do you have? Where's our microphone? We have one here.
Thank you for the presentation. I have one question. As a data scientist, you are doing this energy efficiency on the cloud.
Yes.
But as you showed, in the example, you use it, for example, in Helsinki. Mm-hmm. But what if, that if it is in Barcelona, so the environment, that weather, personalization, many things might affect, that the solution. Do you think about, that doing it, that on embedded system instead of, that doing it connected to the cloud? You can use, that this data-driven stuff on the device because of many things, personalization, latency, all these things.
Sure, thanks. That's a great question. I think there are a couple of things here to unpack. Firstly, doing it in the cloud has one benefit, and it's kind of like what you just addressed. It is to combine data. So one thing is that we can maybe provide an expertise on how to interpret the load, what the load is doing, how much the energy is being consumed. What you're suggesting also is how do we add, for example, weather data or other data that's relevant for how something works. This is a very, very important part. This is exactly why we're partnering in this area. This is a complicated problem overall, and I think that it's easier to share the data when you have all the data in the cloud. It is much easier to collaborate with other players in that area to solve a bigger problem, right? So that's one. 2, do we believe that sometimes it's better doing that on-premise or on asset level? To a degree, yes. I understand there are a lot of applications or places where we cannot necessarily move everything to the cloud either. And then, of course, then you can decide on data collection, sometimes on the industrial control system level as well. That could be then analyzed retrospectively. However, when you collect continuously data and the data gets continuously analyzed by different experts, you're going to get more dynamic results as well. What other questions? We have one here and one here.
Hi,
Hi.
Pablo Valerio for E-Times. Actually, we had a conversation yesterday, and I think I want to go back to that conversation we had. And you mentioned the huge amount of energy that is being used by electric motors, but basically the other part of the energy used worldwide is actually much bigger. So, and one of the things that is happening right now is there is a trend to electrification. And how are you working with companies just to also show the benefits of going electric, and especially when we're talking about industries like transportation, which is one of the biggest, not only polluters, but actually uses most of the fossil fuels today?
Yeah. Thanks for that question. I don't know who read the news this morning, at least the ABB-related news, but I did. One of the things, very concrete things, how we're addressing, for example, the transportation side, is we have spun out our e-mobility business. They just raised 325 million more money. That was today's news for us, and we are definitely investing a lot into the e-mobility side. What we do practically in Motion as well, I mean, we have traction business within Motion, so we do actually help electrifying trains, for example. We work with wind industry to help bring renewable energy, hydro industry to bring the renewable energies. So obviously, you're absolutely right. Just converting motors or addressing the energy efficiency part of industrial motors is not enough. You know, we need to do that other 55% as well. But definitely there's a lot of activities in that front, going to renewables, electrifying mobility, that are very relevant for us as well.
Thank you very much. So basically my question is, in the past we built like tons of roads to transport goods. Now we want to implement millions of devices to transport data and information, to of course leverage it. But what is the sustainability within this process? How are we managing the lifespan cycle of all of these devices? And yes, how are we deal with this future impact? And how are we taking it in account?
Thank you for that question. And that goes probably, again, and maybe I unpack it in a few parts. One thing is, of course, we need to get things moving around. We need to get those IoT devices moving around. We need to get, you know, the machines moving around as well. And for that part, I think it's important that the whole chain, the value chain, is under the radar of sustainability. Now, we've made a pledge as a company, by the way, how we are going to make an impact in our own value chain. We have covered also our suppliers, transportation, as well as partly our customers in that pledge. So that is a very good kind of point. And, you know, one single answer is not probably sufficient to say, oh, we just don't ship it. Not shipping is not an option, obviously, but how you ship and how you work with your value chain is the key here. I mentioned, I mean, DHL is that's very public information. They are our partner, for example, and we're working together with sustainable transportation. And for example, maybe some of you are familiar with Formula E. This is an avenue which ABB and DHL both work with this kind of like sustainable transportation. Second topic, before somebody asks me, because this is almost a guaranteed question, is what about the cloud? Because the data and everything, you know, the data centers are huge energy consumers. Yes, but there's two buts in that. One, almost all of the big data providers or hyperscalers or whatever you want to call these companies are having significant effort to trying to get to net zero on their data centers. So they're really working hard, our equipment included. It's not a lot about ventilation. So the more efficient ventilation you have, the better efficient data centers you have. The second thing is that the most efficient way of doing this is actually a multi-tenant cloud solutions where you do not occupy so much space. We are not moving any more data than it's absolutely necessary. We try to squeeze and squeeze and squeeze the amount of data because that's part of the sustainability picture. And we only use a multi-tenant cloud solution to not take too much capacity and have our own data centers to run just the data we need to do. So there is a sustainability piece also transporting the data. Time is up. I really thank all of you for coming today. I hope you enjoy your lunch as well and the rest of the conference. Thank you so much.